How's everybody going? Who here has heard about the event loop? There's some actual names. You guys are working off a bit. Awesome. Cool. So for those of you who don't know, the event loop is like the main kind of function in your browser, right? So it's a loop, evidently, that's just going to run infinitely, and every turn of the loop, it's going to pick up a task off the task queue, and it's going to execute the task. Which probably raises the question, what's a task? A task is basically just a bit of JavaScript that's running in a certain context. So for instance, if we have the script tag here, this would be two tasks. So the code with the dark background is a task that will run as soon as this script tag has finished parsing. And the code with the lighter blue background is a task that's going to run whenever the browser registers a click event. Cool. So what's a task queue? A task queue is where your tasks go while they're waiting to execute, basically. So if we parse a script tag, we generate some tasks, we have some click events, some timers, maybe make some SHR requests. All of these things generate tasks, and the tasks go in the task queue. And then the event loop obviously pulls one off and executes it. So some important things to note. Tasks in the task queue, it's a proper queue, right? First in, first out. So everything happens in the same order. Everything gets executed in the same order that it happened. The other important thing is that your tasks get executed start to finish, right? Once you start a task, it's going to run the whole way until it finishes. There's no concurrent programming in JavaScript. You don't have to worry about any of that shit. Cool, so that's basically what our event loop looks like. Sort of. It turns out, it's a little bit more complicated than that. The task queue also operates along with the rendering pipeline. The rendering pipeline is responsible for displaying everything you see in the browser window. So you make a change to your HTML, make a change to the DOM, make a change to your styles. It has to go through the rendering pipeline before that change gets shown on the screen. So the rendering pipeline and the task queue work together. Every time you finish executing a task, the rendering pipeline has a chance to run. Thing is though, browsers are pretty clever, and they don't like doing any more work than they have to. So they don't always run the rendering pipeline, even when they could, because there's no point, right? Your monitor only refreshes. A task queue is where your tasks go while they're waiting to execute, basically. So if we parse a script tag, we generate some tasks, we have some click events, some timers, maybe make some SHR requests. All of these things generate tasks, and the tasks go in the task queue. And then the event loop obviously pulls one off and executes it. So some important things to note. Tasks in the task queue, it's a proper queue, right? First in, first out. So everything happens in the same order. Everything gets executed in the same order that it happened. The other important thing is that your tasks get executed start to finish, right? Once you start a task, it's going to run the whole way until it finishes. There's no concurrent programming in JavaScript. You don't have to worry about any of that shit. Cool, so that's basically what our event loop looks like. Sort of. It turns out, it's a little bit more complicated than that. The task queue also operates along with the rendering pipeline. The rendering pipeline is responsible for displaying everything you see in the browser window. So you make a change to your HTML, make a change to the DOM, make a change to your styles. It has to go through the rendering pipeline before that change gets shown on the screen. So the rendering pipeline and the task queue work together. Every time you finish executing a task, the rendering pipeline has a chance to run. Thing is though, browsers are pretty clever, and they don't like doing any more work than they have to. So they don't always run the rendering pipeline, even when they could, because there's no point, right? Your monitor only refreshes probably 60 times a second, so there's no point running the rendering pipeline unless the screen's about to refresh. So instead, your browser's going to wait until a few tasks have executed, and then once the screen's ready to refresh, so once every 16 milliseconds probably, then it will run the rendering pipeline. The important thing to note here, though, is that the rendering pipeline can't interrupt a task, right? Like we just said, tasks run start to finish. So if your task takes a bit longer, it's going to hold up the rendering pipeline. And you're going to start, it's going to delay it being, it's going to delay the browser window updating. So if it's just a couple of milliseconds here and there, it's probably not going to matter that much. But if you have a lot of really long-running tasks that go for more than 16 milliseconds, your browser's going to start dropping frames, and your page is going to start running like this. So if you do have long-running tasks, there's a couple of things that you can do to make them run nicely. First thing is that you can break it up into multiple tasks. So you can create a new task using set timeout. So if you have something that's going to take a long time, then you can do just a bit of it, and then call set timeout to create a new task to do the rest of it. The other option is that you can use web workers, because that's pretty much what they're for. Cool. So now our event loop looks like this. We've got an infinite loop that's running. We're going to pull a task off the task queue. We're going to execute that task, and then if we're ready to repaint, we'll repaint. The thing is, it turns out it's a little bit more complicated than that. If you were to have a look at the relevant spec, which I'm sure is something that we all do in our spare time, you would see that an event loop can have one or more task queues. Now, at this point, I thought, I'm writing this talk, I'm going to put a demo up, but I'll have a look at some code for a browser, and I'll see how many task queues it's got, and we can do a proper example, like from a real-world thing. But I have to level with you. I'm a JavaScript developer. Browsers, it turns out, are written in C++. C++ is mostly punctuation and the word delegate. I don't know what's going on there. So instead, we will look at a theoretical browser with multiple task queues. To be fair, this theoretical browser is actually the example that's given in the spec of a reason why you might want to use multiple queues. So it's not like I just made it up. Somebody else just made it up. So this browser has two task queues. This browser is going to give preferential treatment to click events. So one of the queues is going to have click events in it, and the other queue is going to have everything else. And the way it's going to work is that if there's an event in the click event queue, it will run that task. Once it's run through all of the tasks in the click event queue, then it will do everything else. The rendering pipeline was exactly the same. So we run the rendering pipeline, and then now there's nothing left in the click event queue, so it'll go and run everything else. If I add more things to the click event queue, it's going to switch back to that one. It's just like when you're at the airport and there's the business class queue. You guys will see it, right? So it doesn't have to work exactly like this. Browsers are allowed to execute queues in any order they want. So we could have had three tasks off the first queue and then one off the other queue. We could have done all of the tasks in the event task on Tuesdays with anything they want. The order of the queues is completely up to the browser. But there are some rules. So the tasks still have to be executed in order within the queue. So the thing that arrives first in the queue gets executed first. We don't change that. The other rule is that tasks from the same source have to go in the same queue. So for instance, in Node, there's a queue for all of the timeout events, set timeout events. So all of the set timeout callbacks have to go in that queue. So now, our event loop looks like this. It's still an infinite loop running forever. We're going to choose a queue first now. And once we pick the queue, we're going to pull a task off that queue, and we're going to run that task. And then, if we're ready to repaint, we'll repaint. Cool? Turns out, it's a little bit more complicated than that. We also have microtasks. So what's a microtask? For the purposes of this 20-minute talk, a microtask is a promise callback. There are actually other things that will create microtasks, but let's just stick with this. This is what it will be mostly. So we've got our microtask queue there in yellow next to the rendering pipeline. And if we have a script that runs and it generates a promise callback, that promised callback is going to go in the microtask queue. The microtask queue has a couple of special properties though. So if we run some more tasks, we add some stuff to the microtask queue. The microtask queue is going to get run after every task. So you do a task, and then you do the microtask queue. Even if the browser would like to repaint, it can't. It has to run the microtask queue first. The other thing is that it has to run everything in the microtask queue. So if there's a bunch of stuff in there, it's going to run a bunch of stuff. If you add more stuff to the microtask queue while you're running the microtask queue, then all of that stuff has to run as well. So we can have a quick look at an example of how microtasks and tasks differ in that respect. So here we have a bit of code that just generates tasks. Right, we click the start button, it calls the start function, it's going to print out the number of tasks that have executed, and then it's going to create a new task by calling setTimeout, which is just going to call the same function. So if we do that, we just see we're generating a bunch of tasks. We're not doing anything particularly interesting, but it's working. And it's not like we're stuck in an infinite loop, right? In like a loop within code, they are genuinely new tasks because we know the browser is repainting, we can interact with the screen, we can click stop, and it will stop. We can't click start again though, because nobody implemented that. If we do the same thing with promises, so we've got a button that's going to call this function start, which is going to create a microtask, which we'll call this and then function. In the microtask, we're going to print out the number of microtasks that we've run, and then we're going to create another microtask which does the same thing. So we can click start promising, and immediately everything kind of goes to shit. So because the button has rendered the click, but it hasn't like come back to its original state. I don't know if you can see the cursor there, but it's still a little hand from pointing to the button. I can't like do anything with the text. And click the stop button, doesn't work. Everything is just stuck because we're stuck in that microtask queue, right? Nothing else can execute. We can't re-render the browser. Nothing's going to re-render. It's just stuck, blocked in that one spot. So be careful with microtasks. Like promises are awesome, sure, but if you've got very deep ones that are doing long-running tasks, you could make things sad. So now our event loop looks like this. It's going to run infinitely. We're going to pick a queue. We're going to pick a task off that queue, and we're going to run that task. And then as long as there are things on the microtask queue, we're going to run all of those. Then once that's done, if it's time to repaint, then we'll repaint. Cool? Cool, because it turns out it's a little bit more complicated than that. We also have the animation frame callback queue, which I am just going to call the animation queue because otherwise we'll be here until tomorrow. So you can add things to the animation frame callback queue by calling request animation frame and passing it a callback. Why would you want to do that? If you're doing animations mostly. So I'm using it in my demos here to animate when the browser window slides into the rendering pipeline. So basically I'm removing the slide class from the browser window, which resets everything to its original position. And then I'm adding the slide class, which adds a translate Y, which makes it animate downwards. If I'd done it this way, remember I said before that browsers are clever and they don't like doing work that they don't have to? If I'd done this, the browser would look at it and say, if I remove a class and then I just add the same class back, that's the same as doing nothing. Why don't I just do nothing? So instead, we use request animation frame. And the reason that request animation frame works, you can see from this demo. So the animation queue is in green there next to the rendering pipeline. So if we run a script that calls request animation frame, it's going to get added to the animation queue. And it's going to sit there until the browser is ready to repaint. And then once the browser is ready to repaint, it will run the things in the animation queue. It's similar to the microtask queue in that everything that's in the animation frame queue will run. But it's different to the microtask queue because if I add more things while the animation queue is running, those guys won't get executed. It's just going to run the things that were there when it started. And the reason for this is, like I said, it is for animations. So normally when you're running animations in JavaScript, what you want to do is set up a frame, and then once you finish that frame, you're going to call request animation frame to set up the next frame. But you don't want the next frame to run in this browser cycle, right? You need to wait until the screen's refreshed. Otherwise, you're just going to see the start name of your animation. That's probably not what you're after. Cool. So now, I remember it's getting a bit complicated. So we're going to loop infinitely. We're going to pick a queue. We're going to take a task from that queue, and we're going to run that task. Then we're going to run everything in the microtask queue. Then if it's time to repaint, we're going to get all of the tasks that are currently in the animation queue, and we're going to run all those, and then we're going to repaint. And that is pretty much it. That's how the event loop works, more or less. Which now raises the question, what does any of this have to do with Angular? That's a good question. So one of the things that frameworks give you, which is why it's really handy to use them, doesn't fit, is that they provide a link between your JavaScript and the HTML DOM. So they give you a way when you update your JavaScript to automatically update the HTML. So for instance here, if I have this HTML which is rendering this list of dinosaurs, if I add another dinosaur to the list, I want another list item to be added to the HTML, right? So different frameworks do this in different ways. In React, if you change your JavaScript state, you tell it. You call set state and you say, hey, I've updated the state. You need to run some kind of change detection to work out if we need to update the DOM. Which is great. I mean, it means it only updates the state when you want it to, but it means that you as a developer have to know that that's what you need to do. So it's all very manual. Vue makes it a bit more automatic. So when you create a Vue model, it does some jiggery pokery where it turns all of your variables into properties with getters and setters. And then every time you update your property, it runs the setter function, which is going to update the value and then run the change detection. Which is great because it makes it a bit more automatic. You don't have to do it manually like in React. But it also makes it harder to add properties to your model later on. So Angular instead does it by magic. So every time a task finishes running, Angular is going to run the change detection, basically. So you run a task, change detection runs. And it does that using a library called ZoneJS. Now ZoneJS, if you have a look at the docs, you say, what is ZoneJS? It says, a zone is an execution context that persists across async tasks. You can think of it as thread local storage for JavaScript VMs. Now, you can think of it like that, I guess. Zone gives you this ability to tack a bit of code on at the start and a bit at the end. So you can use it for stuff like, here we've got start timer, so you might want to be timing performance, which is very hard to do with asynchronous code, unless you've got a mechanism like this. How is going to do this to it? It's going to save a reference, and that function is going to call, whatever you want after. So in the context of Angular, it's going to look like this. You call set timeout, you give it a callback. When your timer expires, it's going to run your callback, and then it's going to run change detection. So it monkey patches a bunch of global functions that are available in the browser, set timeout and set interval. All of your event listeners, just like the XML HTTP request, but for reading files, it is just as awful. Promises and request animation frame, and a bunch of stuff that I don't know. Custom elements, that's what that is. WebSockets, mutation observers, which are actually one of the things that make microtasks. So, when you bootstrap Angular, basically what it's doing is a bunch of setup with all of your injectors and all that crap, but also it's creating this ng zone, which is the zone that Angular code runs in. and running that. So what? why do you need to know about this? Realistically, you can write Angular code without knowing how any of this works, but it's super helpful in a couple of situations. And one of those is something which I hope all of you care about, which is testing. You see, when you're running a test code in Angular, it's not running inside the ng zone, so none of the change detection runs. On the one hand, this is great, because it means that your tests run really fast. If anyone not familiar with dinosaurs, this is a Dromaeosaurus, which is a very fast dinosaur. So now you've learned something. It can be a bit annoying, because you might have a test that checks that the DOM updates when you write some JavaScript code, and if you write a test like this, and you are going to be sad. It turns out, though, that the devs who wrote Angular thought of this, and they provided you with a couple of ways to deal with the situation. First of all, you can run change detection manually, which is pretty handy. So in our test, we can just add the fixture.detect changes, which is going to return a promise, which will resolve once all of the DOM is finished updating, and then our code will work. Hooray. The other option is to actually run your code inside a zone. So Angular provides you with this fake async zone that's going to make it a lot easier to deal with all of this asynchronous stuff. Right. So, a lot of people often say that a really good way to get the hang of what code is doing is to have a look at the tests and see what the expected behavior is. And in the case of fake async, this is really true. These tests are really good. So one of the things that fake async does is that it makes sure that all of your promises have resolved before your test exits. So normally you would have to use, if you're using Jasmine, you have to use done. Otherwise, your code runs and the test fails, and then your promise finishes running. So you need to use done to say, hey, I haven't finished yet. Wait until my promises are resolved. So if we were to run in the fake async zone, we don't need to do that anymore. The fake async zone will make sure that all of your promises have resolved before your test exits. So this will just work. The fake async zone also gives you access to a few sort of helper functions. One of those is flush microtasks. So if you have promises that need to execute in your code and you can't wait until the end, you can actually make sure all of your promise callbacks run whenever you like. So for instance, here we call flush microtasks. It's going to run all of the microtasks, just like we did before, and then your expect will work. I'd also provide flush. And flush is going to wait until all of the tasks are run, and then it's going to finish. So we see an example here, a tick. When you pass tick a number, that's like, this is how many milliseconds I want to pass. You might be running an animation with a bunch of stuff going on on a canvas. I assume that's how they made Jurassic Park, JavaScript animations. But because the change detection runs after a request animation frame callback, and you probably don't need that. So one thing you can do is run your code outside of the zone. And you do that by calling run outside Angular. And then when you're finished with all of your heavy-hitting dinosaur animations and you want to get back into the zone and have your change detection back on, you can just call zone.run. The other reason that you might care about how all of this stuff works under the covers is because it's fun. It's nice knowing what's going on, how stuff works, right? If you pick away and look under the covers of stuff, you can find anything.